Okay, so in this video we are going to learn about how to do derivatives of natural log functions. So before we get into the question, which in this case is going to be y equals to natural log of tangent 2x. So let's see how do we do the derivatives of natural log functions in general. So generally, if you have a function natural log of x, then the derivative just looks like 1 divided by the function of natural log, which in this case is just x. So here it becomes 1 over x. Now there's something that we don't see in this function, and I'm going to go over just in a second. So if I try to rewrite this function as in natural log of fx instead of just ln x, then the derivative becomes 1 over fx times f prime x. So where does this f prime x comes from? This f prime x comes from an extension of chain rule. So chain rule says first you do the derivative of the function itself, which in this case becomes this function as whole. So just like we learned a few seconds ago, natural log of x gives the derivative 1 over x. So in this case, derivative of natural log of fx becomes 1 over fx. But now we multiply by the derivative of the function inside it. So the function inside here is fx. So I multiply by the derivative of f prime x. Now we are going to use similar steps to do the derivative of natural log of tangent 2x. Okay, so in this case, now my main function is natural log of tangent 2x. So the function inside the natural log is tangent 2x. Now what's the function inside tangent 2x? Tangent 2x, that's 2x. So when we start doing the derivative, the very first step is do the derivative of the natural log part, which should be just 1 divided by the function itself. So 1 divided by the function of natural log. So that gives me 1 over tangent 2x. Now we multiply it by the derivative of the function inside. So in this case, since the function was tangent, the derivative of tangent is secant square. So that's why we multiply it by secant square. Then we have a 2 here. Where does the 2 come from? The 2 comes from as the derivative of this 2x. So when we do the chain rule, we keep multiplying by the function inside any function until we run out of all the functions. So once we have that, we can just simplify everything and write the numerator as 1 and write the denominator as 1. And that's how you do the derivative of natural log functions. Now let's try to learn about a property of natural log functions. So here we have a true-false question. In this question, they're asking whether this property is true. Is natural log of a plus b always equals to natural log of a times natural log of b? And as you can see, I've said that it's false. So to actually see this, how it works, we are actually going to use example with numbers just to see if it actually works. So here I'm choosing 6 for the value of a and 5 for the value of b. I'm going to put them in a calculator. So once you plug in ln 6 in your calculator, you get this number, 1.791,75947. When you calculate ln of 5, you get 1.609,43791. Now when you try to combine a plus b, that's 11, since the values of a and b were 6 and 5 respectively. Now ln of 11 comes out to 2.39789,527. So now let's try to multiply these two numbers. Not these two, but actually these two. Either way is going to give the same answer, but since you're plugging the calculator, it's actually better if you multiply ln a by ln b, which is ln 6 times ln 5. So that gives you 2.88372562. Now you can see ln of a plus b doesn't come equal to ln of 6 times ln of 5. Hence, our answer false is now justified. Thank you.